Hello guys, welcome to my channel. Yeah guys, in this video, today I will discuss about fundamental data types like int, float, complex, boolean and none type. Yeah. In previous video yesterday, we discussed about the tokens in Python. I hope you understand what is tokens and types of tokens. Tokens is the smallest individual element, and in tokens we have keywords, identifiers, literals, data types, and operators. Yeah, I hope you understand what is keywords and what is identifiers and what is literals and data types. In this video, now you understand the detailed explanation of fundamental data types, guys. Yesterday, we saw that data types are two types. One is fundamental data types and one is collection data types. In case of fundamental data types, we use it to store one value. Memory is used to store one value. In the case of collection data types, memory it is used to store multiple values, guys. And yesterday we also discussed that in fundamental data types, we have int data type, we have float data type, we have complex data type, and we have boolean data type, and we have none data type, right? Uh, in this video, in present video, I will explain you a detailed explanation of all these data types, guys. First, I will explain you what is fundamental data types, and I will explain each and every point in fundamental data types. And then after, I will go to collection data types, guys. In the after completion of these fundamental data types, we will do some problems and we will discuss about operators, types of operators we have in Python. Then after later we will go to fundamental collection data types, guys. Now let's dive into what is fundamental data types, guys. I hope yesterday I told you fundamental data types. Whereas fundamental data types are used to store, memory is used to reserve only one value. In fundamental data types, we have types like int data type, float data type, complex data type, and boolean data type, and none data type, guys. Step by, I will explain you now what is int data type. What is int data type, guys? Guys, in name itself, we can mention that int. Int in the sense integer value, guys. Suppose if you take a equal to 5, a equal to 5, this 5 is called integer, guys. This 5 is called integer. We are defining that into data type. This type of A, the data type of A, variable A, is called integer, guys. It is called integer. Suppose if you mention that A equal to 1.5, the type of variable A, guys, the type of variable A is float, guys. This I will explain you later after completion of it. Now you understand what is it. This is type of integer, guys. The variable of A is type is integer, guys. This it is we call it as int data type. And in int data type, guys, we mention we need to specify the integer, guys, integer values. And coming to detailed explanation regarding int data type, it is used to reserve int data type. Guys, int data type is to reserve, used to reserve memory for integer values, guys. It is used to reserve memory for integer values. Used to reserve memory for integer values, guys. And we can store, it will provide unlimited data, guys, unlimited memory space. We don't have any restrictions. The size of int data type. Int data type, size of int data type is unlimited, guys. Size of int data type is unlimited, and int data type is used to reserve memory for integer values, guys. You remember this was like integer value. Reserve memory for integer value, and int data type is, it will be size of int data type is unlimited, guys. Now I will show you example in practical way also. First listen the theoretical part, and the size of int data type is, now I will show you practical way, guys. Suppose here I am taking variable a, guys. Variable a equal to 10. I am assigning the value 10 to the variable a, guys. Now I am printing the a, it got result as 10. And now I am checking the type of, we have type of a, type of A is C, guys. Here it is showing that type of A is integer, int. This we call it as int data type, guys. It is used to store only one value, and the size of int data type is unlimited. See, guys, suppose if I take B equal to, I taken, see, guys, I mentioned this number. Now I am printing what is B. It is printing this number, guys. And if you want to know, suppose if you want to know the size of B, we have to first import sys keyword, guys. Import sys, I think capital S. Okay. Sorry, guys. Import import sys, guys. If you want to know size of the variable B, sys dot get get size of get size of B, get size of B. See, guys, the size of variable B is 40, guys. The size of int data type is unlimited. We can store unlimited data in int data type, guys. That's, sorry, guys. Here it is, I mentioned capital S, but it is small s, guys. This is the syntax for knowing the size of the variable, guys. Here we are getting size 40. Suppose if I in sys dot get get size of a, suppose if I mention a, see, guys, here I mentioned 10, right? The size of a is 28, guys. 28. See, that this number is very large, right? This number is very large, even though it supports. That's why we here we mention that int data type size is unlimited, guys. Int data type size is unlimited and reserve memory for integer values, guys. This is about int data type, guys. And one more point is, in int data type, guys, we have in int data types, we have mm, Python integer value represent the integer values, guys. These, see, guys, this this integer value can be can be represent can be represent in four format, guys. Four formats we can represent. The whatever value we are mentioning, like a equal to 10, this is integer value, right? This a equal to 10, the value 10 we can represent in four format, guys. The int data type we can represent in four formats. I will let you know what are those four formats. Number one is decimal integer, guys. Decimal decimal integer decimal integer, guys. This is called decimal integer, guys. And one more, we have octal integer value, octal integer value, octal integer, and octal integer, and hexadecimal, guys. Hexadecimal hexadecimal integer hexadecimal integer and binary integer, guys. And binary integer. See, guys, this integer value can be represented in four format, guys. We can represent this integer value by four formats. These four formats called, one is the decimal integer, one is octal integer, one is hexadecimal integer, one is binary integer, guys. Now I will explain you what is decimal integer and what is octal integer and what is hexadecimal and what is binary, guys. Now I will explain you all these four int data types, guys. We can represent int data type in these four formats. Now I will explain you all those step by step, guys. Please listen, guys, carefully. First of all, I will explain you what is the decimal integer. What is the decimal integer? What is the decimal integer, guys? What is the decimal integer? An integer value. An integer value with base 10 is called decimal integer. An integer value, an integer value with base 10 is called decimal integer. It's called decimal integer, guys. The integer value with base 10 is called in decimal integer, and int is created using digits from 0 to 9. It is created from 0 to 9, guys. 0 to 9. This integer is also prefixed with plus or minus. An integer value with base 10 is called decimal integer. The decimal integer can be created from 0 to 9 digits. Apart from 0 to 9, if we mention like another number, we cannot create decimal integer. And it is prefixed with plus or minus, guys. Plus or minus, it will prefix with plus or minus. And now I will explain you what is base 10 value with base 10. I will take one example and I will explain you, guys. Please spare some time and listen carefully. Suppose suppose, guys, now I taken 45, guys. Now I taken 45, not 45, 145, guys. Now I taken 145. See, guys, by default, every integer value is called as decimal integer. Even though if you not mention the base 10, it treated as decimal integer, guys. By default, every integer is decimal integer. The base 10, guys. The value with base 10 is called as decimal integer. These decimal integer can be created from by 0 to 9, 0 to 9 by using 0 to 9 digits. Guys, now I will explain you how to divide this. See, guys, we have to take 145, we taken 145, and this 5 represents 0 index, this 4 represent 1, this 2 represents 1 represents 2, guys. This is the positions, guys, the index positions. For 145 we are making a position index like 0, 1, 2, 3, 4, and so on. If we have more number like 4 digits, 3, we will get 3 here, and we will get 4 here, we will get 3, we will get 4, we will get like that. Like that, from 0 to up to n, we are mentioning the numbers, guys. See, guys, here we mention that base 10. Base 10 means we have to 10 into 10 into 5 power 0, guys. 10 into 5 power 0. We have to treat it like this twice. 10 into the base name, whatever base we have. Like here I mentioned that base 10. Base 10 comes under decimal integer. We have to multiply this base 10 into number, the power of that index value, guys. 5 plus 10 into base value 10 into the value 4 power 1, the value power 1, plus 10 into base value 10 into the value 1 power 2, guys, power 2. Here we got answer like 10. Sorry guys, I did a mistake. I will explain. Sorry, guys. here, sorry guys, I did a small mistake. Again, I will explain you. Here I took 145 guys, 145. Here, this is 145 base 10 guys, 145 base 10. It is the decimal integer. If from 145, we are treating that it is mm, it is 0, it is 1, it is 2. The base 10 power 0 guys, power 0 into 5 into 5 plus previously I did this 0 in this 5 power 0 I mentioned that is wrong. This is the correct guys, this is correct. 10 power 1 base 10 power 1 into 4 plus 10 power 2 into 1 power 2 into 1. Here guys see we have 10 power 0 guys, how much? 10 power 0 1 into 5. Here 10 power 1 is 10. 10 into 4 we got 40. We got 40. Here 10 square 100. 100 into 1. 100 into 1 how much guys? 100. How much we got guys total? Here we got 145, right? 145. This is 145, this 145 is equal, right? This is decimal integer, guys. The value with base 10, the value with base 10 is called as decimal integer. The value with base 10 is called decimal integer, and it represents from 0 to 9. And also it is prefixed with plus or minus. We can mention like plus or minus 145. It is prefixed with plus or minus. This is about decimal integer guys. Now I will explain what is octal integer. Now I will explain what is octal integer. Octal integer. Octal integer. Octal integer guys. Now I will explain you what is octal integer. An integer, see guys, for every integer the definition almost same guys. Here the change value is this base value. For decimal integer base value is 10. For octal integer the base value is 8 guys. An integer value with base 8 is called octal integer. Is called octal integer. The integer value with base 8 is called octal integer. Base 8 is called octal integer guys. The octal integer, it it consists of digits. It consists of digits from 0 to 7 guys. See guys, here we have base 10 in decimal integer. The digits represents from 0 to 9. Here we have octal integer. The value with base 8 and the digits consists from 0 to 7 guys. 0 to 7. And it is also it is also prefix with is also prefix with 0 comma small o or 0 capital O guys. 0 small o 0 capital O. It is also prefix with 0 small o 0 capital O guys. Now I will take one example. Uh, then you will understand what is octal integer guys. For example, if we take um, you take 140 guys. Suppose if you take 145, 140, if you take 140 guys with base 10 guys, with base 10, you take 140 with base 10. This is 140 with base 10, we call it as decimal integer, right? Previously we discussed base 10 is called decimal integer. Now I am converting this decimal integer into converting octal integer. How to convert decimal integer into octal integer, guys? Now I will explain you. Yeah, take 140, take 140. I hope you all know from childhood days onwards, we are learning this division pattern. I hope you all know. Guys, see here at the end, what we need? We need octal value. Octal value, base value, how much, guys? Octal value, base value is 8. Octal value, base value is 8. So, we need to divide this decimal integer with base value 8, guys. Base value 8. See guys, how many times it will divide, guys? If for 8 ones are 8, 8 2 is 16. First one time it will divide 8. The remaining how much it will get? 60. And next 7 8 is 56, 17. Remainder how much we will get? 4, right? 4 we will get. And see guys, 140, if we divide 140 with 8, first we will take 8 ones are 8 and the remainder is 60, guys. 6 and we taken 0 and 7 is 56, guys. 56, the remainder is 4, guys. The remainder is 4, guys. And again we have to divide 17 with 8 and here we get 8 twos, 8 guys, 8 twos, 8 to 16, right? 8 twos, 8 to 16, the remainder we will get 1. The remainder we will get 1. And again if we divide with 8, it won't divide, right? If we divide the value 2 with 8, it won't divide, guys. So we have to take 2. So here we got reminders for like 4, 4, 1, 2, right? So we have to write octal value as 2, 1, 4, guys. We have to write from reverse order. We have to take the octal value from reverse order. So the output is 214, guys. 214. This is octal value. This we can represent by 214 base base 8, guys. I hope you understand how to convert decimal integer into octal integer. First, you need to think from which number to which number we have to convert. Suppose we have to convert octal integer means we have to divide with 8, guys. We have to divide with 8. Because why you need to divide with 8? Because the because the octal because the octal integer base value is 8, guys. That is the reason why you have to divide with 8. So after dividing, you will get reminders. All these reminders, if you mention in reverse order, that is the output of the octal value for decimal integer. From decimal integer to octal value, guys. This is the process, guys, to convert decimal integer into octal integer. Now I hope you understand what is octal integer and what is decimal integer, guys. Suppose guys, if you have 214 with base 8, guys, 214 with base 8. Suppose if you want to convert 214 214 base 8. Suppose if you want to convert this is octal number, right? Because we have base 8. If you want to convert octal number into decimal number, if you want to convert octal number into decimal number means you have to multiply, right? You have to multiply. We need to take it as a 2, 1, 4, and here you have to mention this is 0 position, this is 1, this is second position. So the value of base is 8. So we have to write it like 8 power 0, 8 power 0 into 4 plus 8 power 0 into 4 plus 1, 1 power 1, 1 power 1 into 4, 1 power 1 into 1, 1 power, sorry guys, 8 power 1 here, 8 power 0 into 4 and 8 power 1 into 1 plus 8 power 2 into 2 guys. 8 power 2 into 2. Here how much we will get? Power 0 always 1 guys. So we will get here 4 and 8 power 1 8 and into 1 8 ones are 8 and 8 power 2 64 and 64 into 2 we will get 128 guys. 128. If you sum it 128, 8 and 4, if we add all these three, we will get output as 140 guys. We will get answer as 140. This is the process guys. If you want to convert octal, sorry guys, octal integer into decimal integer guys. This is the process to convert octal integer into decimal integer. If you want to convert octal integer into decimal integer, you need to multiply with base 10, base 8. Suppose if octal value, base value is 8 means we have to multiply with 8 value. Suppose if you want to convert decimal into octal value, you need to divide with octal base value. The end output, in which format you need output, based on that format you have to take base value guys. I hope you understand what is octal integer and what is decimal integer guys. Now let's dive into hexadecimal integer. Well, what is hexadecimal integer guys? Now I will explain you what is hexadecimal integer. Hexadecimal integer. Hexadecimal. Hexadecimal integer guys. Hexadecimal integer guys. Hexadecimal integer guys. An integer value. An integer value. An integer value with an integer value with base 16. Base 16. An integer value with base 16 is called hexadecimal integer guys. Here in previously we saw that an integer value with base 8 is octal integer and an integer value with base 10 is called decimal integer. And here guys, an integer value with base 16 is called hexadecimal integer guys. Hexadecimal integer. This integer consists of from values from 0 to 9, 0 to 9, 0 to 9, or small a to small f, or capital A to capital A to capital F guys. We can mention this integer value from 0 to 9, small a to capital F, small f, and capital A to capital F guys. Here we treat it as small from 0 to 9 as usual 0, 1, 2, 3, 4 up to 9 guys. Up to 9 we will write as usual. From 10 to from 10 to from 10 number onwards we have to mention from A to F guys. We take 10, 11, 12, 13, 14, 15 guys. Here the 10, the value 10 represents A. The value 11 represents B. The value 12 represents C. The value 15 represents F guys. I hope you understand what is how we have to consist from small a to small f. And also we can mention this small a as capital A, and we can mention this small b as capital B, and we can mention this small f is also capital F. We can write it as also capital F guys. This is the hexadecimal integer guys. This is hexadecimal integer. I hope you understand what is hexadecimal integer. The value with base 16 is called hexadecimal integer. It's called hexadecimal integer guys. Guys, we can also represent this hexadecimal integer with um, we can also represent as 0, 0. We can also represent as, we can also, we can also represent as 0 small x, 0 small x, or 0 or 0 capital X, guys. We can also represent by 0 small x and 0 capital X, guys. This is about hexadecimal integer, guys. This is about hexadecimal integer. Now I will take one example, guys. Then you will get understand what is hexadecimal. Now I will take one example, guys. Guys, now I will take one example. See, guys. Now I am taking example number 170, guys. Here I took, here I taken 170, here I taken 170 with base 10, guys. Guys, with base 10, what we call it as a number with base 10. A value with base 10, we call it as a decimal integer. A number with base 10, we call it as decimal integer, guys. I hope you know what is decimal integer. Just now we discussed about decimal integer. And now I am converting this decimal integer into hexadecimal. Now I am converting this decimal integer into hexadecimal, guys. Please listen, guys. Listen carefully. I will explain you, guys. First of all, if you want to convert one integer into another integer, first of all, you have to know what is your destination. Your destination is to convert hexadecimal, guys. Hexadecimal. The value of hexadecimal base value is 16, guys. Base value is 16. So you have to divide the number 170 with base value 60, guys. Base value 16. See, guys, now we will divide 170 with the base 16, guys. 170 with base 16. Here 16. There 16 tens. 16 tens are 160, guys. We will get a reminder as a 10. And 10 is not divisible by 16. So we are taking directly 10 as 10. While representing these reminders into hexadecimal, we need to mention as from reverse order, guys. What we got 10 and 10, guys. 10 and 10. Yeah, guys, we already now we discussed that from 0 to 9 only we have to represent only numbers. From if we got like number 10 or 11 or 12, we have to represent from small a to small f or capital A to capital F, guys. So now we got here 10. 10 means we have to represent this 10 as small a or capital A, anything. Here also we got 10. We have to represent small a or capital A, guys. The output of hexadecimal integer is small a and small a, guys, or capital A or capital A. This is the output of hexadecimal, guys. If you want to convert decimal integer into hexadecimal integer, we have to divide with destination base value. Destination base value is 16, guys. We have to divide, we have to represent. And also, we can also represent this like output as 0, output as 0, 0, small x, 0, small x, and small a and small a, guys. We can also represent as 0, 0, capital X and capital A and capital A, guys. This is the output of the hexadecimal integer. Suppose if you want, suppose suppose if you want to convert hexadecimal into hexadecimal into decimal integer, we have to multiply with base value, guys. Here I taken 0, small x, small a, and small a, small a and small a. With this is hexadecimal, so base value is 16. This is hexadecimal value, guys. So the base value 16, we call it as hexadecimal value. If we want to convert this hexadecimal into decimal integer, If you want to convert this hexadecimal into decimal integer, we have to multiply. See guys, this is representation guys. We no need to consider this 0x. We need to consider only small a and small a. We know we need to consider only small a, small a. So if we take small a and small a, this represents position index 0. This represents 1. Here we have to multiply with 16 power 16 power 0 into a 16 power 0 into a plus 16 power 1 into a 16 power 1 into a guys. Here we taken hexadecimal value like a and small a. We need to multiply with the base value 16. Why? Because it is hexadecimal integer. If you want to convert decimal integer, we need to multiply with 16 guys. 16. Always 16. Any value with power 0, always 1 guys. Always 1. And we are multiplying with a. See guys, the A I already explained you the A value 10 and B value 11 and C value 12 and F value 15. So here we have A, so we have to take it as 10. Here take it as to 10. And here we have 16 and here we have 16. We have 16 power 16 is comes 16 and the value of a is 10. So 16 into 10 we will get 160 guys. We will get 160. Here 10 and here 160. The sum of 160 plus 7 we will get 170 guys. I hope you understand what is decimal integer, what is what is octal integer, and what is hexadecimal integer, guys. I hope you understand these three integers and you know how to convert from one integer to another integer, and you know all these things, guys. And now I will explain you what is. We have one more integer, guys. We have one more integer called. We have one more integer called binary integer, guys. We have one more integer called binary integer. Now I will explain you what is binary integer. What is binary integer, guys? Binary integer. Binary integer, guys. Now I will explain you what is binary integer. An integer, an integer, an integer with base 2. An integer with base 2 is called binary integer, guys. Binary integer. See, guys, here with base 16 hexadecimal and base 8 octal integer and base 2 is called binary integer. Base 2 is called binary integer, guys. This integer can be represented as 0 small b or 0 capital B, guys. Like here 0 small x and 0 capital X. Here we can represent binary integer with 0 small b or 0 capital B, guys. Guys, these binary integer, the number represent in zeros and ones format, guys. 0 to 1, 0 to 1 digits. Here we represent digits from 0 to 9 and here we represent 0 to 1, guys. Here we have to represent 0 to 1. Represent 0 to 1. So I will take one example and I will explain you guys. Suppose if we take example, if we take example 45, guys. If we take example 45 with base 10. See guys, the value with base 10, we call it as which value? We call it as which type of integer? The value of base 10, we call it as decimal integer. We call it as decimal integer, guys. Now let's convert this decimal integer into binary integer. binary integer. Convert this decimal integer into binary integer, guys. First of all, we have to know what is the destination we have to convert. We are converting from decimal to binary. We are converting from decimal to binary. The destination binary base value is 2, guys. Base value is 2. So we have to multiply this number 45 with base value 2, guys. With base value 2. So we are dividing the 45 with base value 2 with base value 2. Here, how many times it will divide, guys, with 2? 2 twos 4, and again 2 twos 4. You will get 44, and the remainder is 1. Again, we have to divide with 2, and 11 times it will go. We will get value 0, guys. And again, we have to divide this 11 with 2, and 5 times it will go. 2 5 10. Again, we will get output as 1, guys. Again, we have to divide this value 5 with 2. So we will put 2 is 4. 2 times it will go. Again, we will get output. Again, we have to divide this 2 value with 2. We are, one time it will go. We will get output as 0, guys. Guys, if you want to represent from 1 to binary integer, we have to take it from reverse order. We got 0, 1, 1, 0, and 1, guys. 0, 1, 1, 0, and 1, guys. This is the binary value of 45, guys. The binary value of integer 45 is 0, 1, 1, 0, 1, guys. This is the final output of binary value, guys. Suppose, suppose, guys, if you want to convert this binary value into this binary value into decimal integer, you need to multiply with base value 2, guys. You need to multiply with base value 2. See, guys, now we will see how to convert from binary value into decimal value. Now we got output as 0. We can represent like this also 0, small b or capital B. We got output as 1, 0, 1, 1, 0, and 1. We have to convert this binary value into decimal value, guys. Decimal value. See, guys, here this binary value, this this binary value, the base value is 2. Base value is 2. So we have to multiply this binary value. See, 0b is representation of binary value. We no need to consider this 0b. We have to consider 1, 0, 1, 1, and 0. Let's take positions of these values. It starts from 0, 1, 2, 3, 4, guys. 1, 2, 3, 4. So here we have base value 2. So we have to multiply with 2, guys, of these numbers. We have to multiply like 2 power 0 into 0. We have to take first value 0 plus, and again base value 2, and power is 1. 2 power 1 into 1, guys. And again plus base value 2. 2 power, here we have 2 power 2 into 1 plus, again we have to take base value power 3 into 0 again plus, again base value power 4 into 1, guys. See, guys, if you sum all these values, you will get output as same value like 45. We will get decimal integer 45, guys. This is the process of converting from binary to decimal. See, guys, I hope you understand what is decimal integer. Again, I will recap once. Now we are discussing fundamental data types, guys. In integer, we are discussing about int data type. Int data type, the memory used to reserve memory for integer values. Integer values is called int data type, and the size of int data type is unlimited, guys. Unlimited. This int data type we can represent in four formats. One is decimal integer, one is octal integer, and one more is hexadecimal integer, and one more is binary integer, guys. I hope you all know what is a decimal integer and what is octal integer and what is hexadecimal integer and what is binary integer. And we also know how to convert from decimal integer into octal integer and octal integer into decimal integer. And again, also you know how to convert hexadecimal into decimal integer and decimal to hexa and decimal to binary and binary to decimal, guys. Now we will move to what is float. What is float, guys? We will move into float data type. We will move into float data type, guys. Float data type. We'll move into float data type. Guys, in Python, float data type can be represented in two formats, guys. Float Float data type is representing two formats. Representing two format, guys. One is, suppose if you take n equal to 1.5, this is for float value, guys. Because the value of n, the variable n of value, we are assigning the value 1.5, guys. This 1.5 is fractional value. This is 1.5 is fractional value. This value we call it as float value, guys. The type of n, here type of n is float, guys. I will show you now. Here, suppose if you take n equal to n equal to 1.5, n equal to 1.5, here I will show you. Here I will show you n equal to 1.5, guys. Now I am printing n value. We got 1.5. If I print, type of n, we will get type of n. We will get float, guys. See, guys. Here we got int type and here we got float. You forgot about class, guys. Later I will explain what is in coming sessions. I will explain what is class. Just now you focus on this float type. This n value is float type, guys. This n value is float type. N value is float type, guys. We can also represent this same 1.5 as 15, 15 into e power 15 into e power minus 1, guys. 15 into e power minus 1. See, guys, 15 into 15 into e power minus 1. The value of e power minus 1 is the value of e power minus 1 is the value of e power minus 1 is 1 by 10, guys. The value of e power minus 1 is 1 by 10. 1 by 10. So we can write it as 15 into 1 by 10. 1 by 10 is equal to 1.5, guys. 15 into 15 by 10 equal to 1.5. I hope you understand what is float data type. Yes, yes, guys, what is float data type, how we can represent float data type. I hope you understand now. You got clarity what is float data type. Float data type, guys. and and we have one more data type, called complex data type. See, complex data type, guys. One more data type called complex data type. Complex data type, guys. complex data type. Complex data type, guys. Complex data type, it is used to reserve memory for complex value, guys. This float data type used reserve for float value. Int data type used to reserve memory for integer value. This complex data type used used to reserve memory for complex values, guys, or complex numbers. Use it to reserve memory for complex numbers. See, guys, we said that it is used to reserve memory for complex numbers. Let's see with example how to reserve memory for complex value. Guys, in complex data type, we have two values. In complex, in complex data type, complex data type, we have two values. We have two values. One is we have two values. One is real value, and one more second value is imaginary value. Imaginary value. We in complex data type, we have two type of values, guys. One is real value and one more is imaginary value. Let's see, guys, what is the real value and what is imaginary value. Suppose if I take c equal to if I take c equal to 1 plus 1 plus 2j, 1 plus 2j. Guys, this is the complex data type, guys. We can represent the value like this. This 1 plus 2j is complex data type. The value 1 is real value. The value 1 is real value. And the 2j, it represents as imaginary value, guys. This 2j represents imaginary value, and it always gives output as float value, guys. If you print imaginary, if you print real value and imaginary value, if we print if we print real value and imaginary value, if you print real value and imaginary value, it will give it will give it will give output as it will give output as float value, guys. I hope you know what is float value. Just now we discussed about float value. It will give output as float value, guys. Let's see. Now I will execute and I will show you how it will give. Then you can able to understand what is complex value. See, guys. Now I am taking c equal to c equal to 1 plus 1 plus 2j 1 plus 2j, guys. Now I am thinking type of type of c type of c is complex, guys. This this 1 plus 2j type is complex. This 1 plus 2j is complex. Suppose if we think real value, it will give. Suppose if you think c dot real means it will give 1. Just now I said that it will give output as float value. See, guys, actually we have here number 1, but it given 1.0. Suppose if you print c dot imaginary value, it will print 2.0. It will print 2.0, guys. But here in complex data we have only 2, but it will print 2.0. It always print float value as a result. I hope you understand. what is imaginary complex data type, what is complex data types, and what is float data type, and what is integer data type. Now, let's dive into boolean data type, guys. Boolean data type. Boolean data type, guys. Now I will explain you what is Boolean data type. See, guys, Boolean data type is very simple, guys. Boolean data type is it is used to allocate memory. It is used to allocate memory for Boolean value. For Boolean values. The Python Boolean value represented by the will allocate memory for Boolean value. What is Boolean value? In Python, we have two types of Boolean values. Yes. We have two types of Boolean values. One is true, one is true, and one more is false. Yes. One is true and one more is false. We can represent Boolean data type by these two values. One is true and one is false. One is true and one is false. Yes. And also true also represent as number one and false also represent number zero, guys. False also represent number zero. Now I will show you, I will execute and I will show you, then you will get clarity. See, guys, here I am typing true. Suppose if I take c equal to true, c equal to true, type of C, we are getting like Boolean. Here we are getting Boolean. The type of C is Boolean. The type of C is Boolean. See, that is about that is about Boolean data type, guys. We are only represent it is as true and false. Represent as true and false, guys. And we have called one more data type called none data type. None data type. See, guys, in name itself, it is saying that it is none. It is none. It is used to reserve memory for none value. For none value, guys. Used to reserve memory for none value. For none value, guys. If suppose if you want to, if you take a equal to I want 10. Suppose if you don't want, if you want to keep a is ideal, you can mention a equal to none. A equal to none. It doesn't hold any value. It, the variable here, now it doesn't hold any value, guys. That value we are representing as none value. This is none data type. If we variable doesn't hold any value, it is represented as none data type. Here the value 10, it holds the variable a, it holds the value 10. So here it is not comes under none value. But here the variable a, it holds the value none. So it comes none data type. I will show you and I will execute and I will show you. A equal to none. Here I mentioned type of type of A. Type of A is none type. Type of A is none type, guys. I hope you understand what is none data type. See, guys, today we discussed about fundamental data types. In fundamental data types, we discussed about int data type and float data type and complex data type and boolean data type and none data type, guys. In int data type, we have four more data types like decimal integer, octal integer, hexadecimal integer, and binary integer, guys. And we discussed what is a decimal integer, what is octal integer, and what is hexadecimal integer. and what is binary integer. We discussed all these things and we moved into what is float data type and what is complex data type and what is boolean data type and what is non data types, guys. These are the fundamental data types, guys, we have in Python. Tomorrow we will come with new topic, guys. Up today, up to here is only we discuss fundamental data types. Tomorrow we will discuss about operators and strings and later collection data types, and we will discuss some programs related to whatever we learned till now, guys. Thank you, guys. Thank you. Bye. Thank you, guys.